Okay, so this segment is going to be all about your carbohydrates. And this is the picture that you have in your notes. And it talks about some simple carbohydrates up on top. Okay, so we have monosaccharides, or for short, monosacchs. You can see they're usually one ring or one carbon chain. You can have them be straight. Most of the time we see them in rings. And then we have, after a condensation reaction, we have what's called a disaccharide, or the disacks. So these are double rings, 2 rings. Or a longer carbon chain, I guess. And then we have what's called polysaccharides. And that's the long complex chain of rings. In this particular case, it's a chain of rings that makes us our larger macromolecules. So I just want to make another little note about monosaccharides. You can see them up here. Actually, they're labeled. So these guys are called your simple sugars, and these guys are called your complex carbohydrates. Your monosaccharides, again, are, and your disaccharides are your sugars. That's these guys. These guys will be your starches. We're going to look at cellulose. And we're also going to see glycogen. That falls into those guys. So those are your polysaccharides. A couple other notes about carbs in general before we move on that you can see from here. I just change my color here so it stands out. Taking a look at the names of the simple sugars, they all end in OSE. So you have glucose up there, you have sucrose up there, and then down at the bottom here we would have, I'm just going to say it's the most simple of these guys, which is amylose. So carbohydrates tend to all end in OSE. That's another signature of a carbohydrate. And once again, remember that the signature functional groups here are the alcohols and the ether bonds. Those are your signature functional groups. Okay, let's see if I can find a picture of monosaccharides for you guys. I believe so. My goodness, I don't know if that was a good idea. Let's see if we can find something better. All right, that's better. That's a better picture. So these are 3 of the most common monosaccharides. Whoops, sorry about that, guys. Oh my goodness, it did it again. monosaccharides. One of the cool things about these particular monosaccharides is that they are all C6H12O6. And you should remember, or I hope you remember, that if they all have the same molecular formula, but as you can see, they have different molecular shapes, that means that these guys are all isomers. So I'm going to change colors here, and let's do purple to show you the difference. First of all, this one, you should see that it's a 5-carbon ring. Oh my goodness. Hang on, guys. Trying to get this back for you guys. All right, so this is a 5-carbon ring. That means that, well, that's not even correctly said either. It's a 5-sided ring. How about that? Because obviously this is an oxygen in the ring. That's where our ether bond is. So there's a carbon here, there's a carbon here, a carbon here, a carbon here. Here's our carbon, and here's our carbon. One here, and one here. 1, 2, 3, 4, 5, 6. So those are the carbons that are these 6 carbons in our formula. Here we have 5 carbons in our ring, but we have a 6-sided ring, and our last carbon is up at the top there. And the differences here are between where the OHs sit. And in all honesty, this is the only difference between those two molecules. If you look at all the rest of the OHs, they are in exactly the same position. So that is the only difference between glucose and galactose. So I do want to talk to you about the monosaccharides themselves. Glucose, I hope you all know, is what we refer to as somebody's blood sugar. It's also what's used in cellular respiration, which I hope you know by now. Galactose is a monosaccharide that's in milk sugar, also known as lactose. And fructose is fruit sugar. So it's one of the sugars that we find that make fruit sugar. So these are our major monosaccharides. Again, they are all isomers. That's really important to know. And the only difference between glucose and galactose is where that one OH sits. Fructose is a little different because it's a 5-carbon ring, and that's a little bit easier to pick out as being an isomer. But again, they are all monosaccharides, and therefore they all have the same molecular formula. Okay, let's see if I can find us some disaccharides. Not the best picture. Your notes have much better pictures than these guys. This is also an example of how we make a disaccharide. So this shows you, it's going to show you the condensation reaction as well. But I want to talk about disaccharides in general here. So two of the most common ones that you're going to come across are sucrose and lactose. And rather than draw their structures, I'm just going to tell you what monosaccharides are together. So we take a glucose and a fructose, and that's how we get sucrose through a condensation reaction. And just to make sure we're on the same page and that everybody knows, this is your table sugar. So that's the sugar you put in your tea or your coffee. It's the sugar that, you sprinkle on your Kix or your cornflakes. Lactose, hopefully, you all know is milk sugar. And lactose is a glucose plus a galactose monosaccharide. And that's how we get lactose. So these are the things that you're taking in the different products that or foods that you eat. And this is what is going to have to be metabolized, quote unquote, before you actually do cellular respiration. So now those are your disaccharides. Okay. So then the last thing to talk about would be your polysaccharides. And these get really, really, really complex, but I do want to talk about, some of your basic ones. So again, you have your starches, you have cellulose, and you have glycogen. So starch is a plant storage form for sugars. Cellulose is a plant structural form. Cellulose is in the cell walls around your plant cells. So this is a structural carbohydrate. This is a storage form. This storage form, is what will be used by either us, animals who are eating the plants, or the plant itself if it needs it. Glycogen is an animal storage form. So these are ways that we're storing the sugar molecules for when we need them to break down to release the energy from inside of them through cellular respiration. Okie doke. Let's see what else. Make sure that I have everything for carbohydrate. Looks like I do. I do want to add, I think I'm going to put a note in here. I think I need to show you guys something. So before I release you to go find lipids, I do want to make a special note here. So we're looking at these molecules that have lots of carbon in them. And I'm just going to draw our it's either glucose or it's galactose. It really, doesn't matter except for this carbon right here. So once again, just remember, everywhere there's a point, there's a carbon. So how do we denote what carbon is what? So we're going to talk about numbering carbon atoms within the molecule. The rule is clockwise, number clockwise with the carbon closest to 12. So, if this was my imaginary clock, and here is my 12, then this would be carbon 1, this would be carbon 2, this is carbon 3, this is carbon 4, this is carbon 5, and that's carbon 6. So now we could say on glucose, the alcohol group on carbon 4 is, I don't know, up. I think it's the other way around. I really think it's galactose that it's up. Whereas on galactose, the OH on carbon 4 is down. And if you were really in organic chemistry, there's words that we would actually use that stipulate the up versus the down, but we don't need to do all that. So this is good enough for now. So again, we number carbons based on their position clockwise, and we start closest to the 12 o'clock on a face of a clock. So this would be carbon 1, 2, 3, 4, 5, 6. And again, if we were talking about how glucose is different than galactose, we would talk about where the OH is positioned on carbon 4. This is going to become important to us when we talk about DNA, and I just thought that we should kind of address it now when we're talking about these carbon molecules in here. All right, we are done with carbohydrates, and you can move on to lipids now.